going to talk to you guys about the Smart Kiln controller, and my name is John Mosier.
I'm Owen Waller.
And I'm Leah Ranney.
For the agenda for today, we will first introduce you to what a solar kiln is, as well as what our smart controller will do. Then followed with this with how we are going to actually approach this problem, and what our timeline, budget are for this, as well as just a brief conclusion to wrap it all up.
The abstract of the project. The Smart Kiln controller will allow the user to monitor accuracy and efficiency of the kiln for small businesses and hobbyists. This controller's intended use is with the solar kiln to be most cost efficient, but can be used with any kiln. This controller will also replace the need of supervision by automating the kiln independently. And monitoring data will include the lumber weight, humidity, conductivity, temperature, and light levels. And all of this information will be displayed to the user on an LCD screen.
So using this controller in combination with the solar kiln and all will increase efficiency and also reduce costs. So the dry wood will be able to be monitored to the user's desired level, and then they'll be able to see the information on the screen and then go retrieve the wood whenever it reaches the levels that they want. So this also decreases the waste use of materials. So wood can be over dried or under dried. Over drying usually leads to cracking, and then under drying leads to some mold can develop and then some pests. So whenever you can retrieve your product at the optimal time, then it saves the resources as well. So going a little bit into the background for all of the non-kiln knowers out there, it starts off with two types of kilns. Usually when you are a craftsman or any sort of crafter, then there is a dehumidification kiln. This usually uses electricity with a dehumidifier and also a heater, whereas the solar kiln uses less electricity since it is just using it to power the fans to circulate the air around. Right now, there are two current ways to control a kiln. So the first one would be to manually go out to the kiln and check the wood for the moisture content. As you can see, it looks similar to a shed, so you'd probably just walk out of your house and go check it, open up the doors there. And then there's also a basic temperature controller similar to a thermostat that will turn on a fan after it hits a set temperature. So the current design of the solar kiln is typically placed outdoors, so that way the heat from the sun can come in and start drying up the wood. And then as you can see from the picture, there are 4 different white squares at the top, and those are actually fans to begin to circulate the air around the wood.
For our project, we had a few objectives to make sure everything runs smoothly and we create a good product that we're proud of. First was to create a low-cost, reliable alternative to kiln supervision to improve man-hour efficiency, optimize small businesses, or just let hobbyists use it just as a cheap tool to have something on in the background. Next would be to implement a system that would decrease the amount of cracked or molded wood in solar kilns, because there is a lot of room for error, especially if you're leaving something go. Sometimes you forget to check on. Third is to design an integratable device that monitors and displays kiln conditions for enthusiasts and hobbyists. Now this would just be knowing better what's going on in the kiln, knowing how your wood is drying, how fast it's drying, just increasing readability of the situation for all people who are interested. Fourth, we dry 2 pieces of wood during the project and get them improved by a 1819 Makerspace employee to ensure that we have a solid product that's doing exactly what we want. And fifth, we made it a point to develop an audible notification to the user when the wood has reached desired moisture so that you don't have to constantly keep thinking and checking and going back to it.
As for the technical approach for this project, we split it into 3 phases. This starts with the hardware testing, the second phase is design and setup, and finally we finish with demo and revision. Under the first phase, we'll begin by just gathering information about solar kilns and doing some more research, as well as testing those sensors, making sure everything works as intended, and then also gathering materials to make our testing environment, as we can't use a full-size solar kiln right now. Under phase 2, we'll first begin by preparing pieces of wood for our experimentation and begin assembling the sensors and our microcontroller into a complete system, as well as doing the coding for it. And then phase 3 will be our testing, where we start experimenting on the pieces of wood and revise things as needed. As for how the sensors are integrated to the microcontroller, it will begin by your sensors currently reading out all the information about the wood. The conductivity will be sent to a lookup table to convert that to an equivalent moisture content, and then all of this will be calculated as a percent change against past data points. And this will all be displayed on the LCD, where we'll display one point at a time, and then if a button is pressed, you can cycle through different menus.
As for the timeline of the project, we decided to front load a lot of the technical work. So all of the hardware testing, the acquisition of the kiln, really setting it up and creating it, just because sometimes things go wrong in these projects and we don't want something to go wrong and it pushes it back 2 to 3 weeks, which would effectively be 60% of the total time. So we really started out with creating the sensors, getting the kiln running, and then setting it up, and then giving us a lot of time to test wood, like making sure we have a lot of leeway in our project.
And then going more into the budget here, I actually break it down into each material that we use. So for the software side, we did use the free MPLAB software suggested by the professor of the course, and as well the demo board and microcontroller given to us, even though that cost is accounted into the grand total if someone else were to pick up our project and make it. We use the suggested sensor kit, and then other materials that contribute to building the small scale kiln would be the case fan to provide some air, wires to connect everything, a load cell to measure the weight of the lumber, the box that it all goes in, and then finally the unfinished wood pieces, which would be our test pieces through this experiment. And then next is just a pie chart to show you the breakdown. Here you can see that the sensor kit and maybe the case fan would cost the most of it. But overall, this is worth the cost outweighing any wasted material, and it can also contribute back to some time.
In conclusion, the Smart Kiln project is a system that can monitor the moisture level of the wood and output information to the user. And note that there's currently no monitoring system like this on the market. During our development, the testing phases will ensue practical use, and the testing environment will, as closely as possible, simulate a solar kiln with moderate heat, fans, and wood pieces to scale the testing environment. Thank you very much for listening to the solar kiln presentation. I'm Owen Waller.
I'm John Mosier.
And I'm Leah. Thank you.